So the last section, we go through the Docker theory, right? All of you. Docker theory part. So today we will cover the installation process, how to deploy a containerized application from scratch using Docker file and the step-by-step process. Everything we will cover today. Okay. For that, first we need to install Docker. Okay. So where we are going to install Docker, we need a machine, right? A EC2 machine. So this is our EC2 machine. And on top of the EC2, we will install any operating system like Ubuntu or Linux OS, okay, OS. On top of the operating system, we will install Docker or Docker engine. Then this is fine. Now we got a platform, okay, to run our containerized application on top of Docker. So we need to write up a Docker native file that is called a Docker file. D capital, okay, Docker file. So inside the Docker file, we need to define our application details, okay, like application code, application steps, because we do some step-by-step process, okay. Then application dependencies, application libraries, everything we need to define inside the Docker file. Docker file is a text file. It's contain a lot of Docker instructions, okay. We called as instructions. So uh, after write up the Docker file, that steps, there is some steps are there. First, we need to build. So after build, we will get a image, build image. The image is a wrap up of a Docker instruction. Okay, what are the things that we define the Docker file? It will starting to build and downloading the contents. What are the things that we install? I mean, define in the Docker file. It will do everything. Okay, then it will wrap a image, a final image. That image contain that application. Okay, we can run the image actually. So the image contain the code, the dependencies, everything to run the application. That's all. Then this is a command actually, Docker build. Then we need to run Docker run command to running our application. So we can see the container is starting to running with our application. Inside container, we can see the application. So here it will create, okay, a isolated environment to run our application. Container, Docker container. So we can jump into the lab, right? Anyone have a doubt? Sure. Okay. So first I'm going to
A quick
launch a,
question, Taufik.
yes,
After we are getting the Docker image, are we gonna like where we gonna store that image?
yes. You can store this image as well. For example, in this phase, okay, the second phase, we got a build image, right? So we can save this image to registries. Two types of registries are there. One is a central cloud-based registry, that is Docker Hub. Otherwise, we can set up our own registry, okay? That is Docker registry for keeping private images. So we can first we need to set up our own registry. Then we need to keep image to that registry as well. We can make it as public or private as per the requirement. So the
So
next time, okay, if you keep, if you save this image, next time we did not go to the Docker file creation stage and build stage. We can run the image directly. For example, I have one more mission there. Okay, so I need to run the same application. So these two steps not needed actually. So we can pull the image from the Docker Hub and run it here in this EC2 machine. If we have the same image.
So in this lab, are we gonna pull the image from the Docker Hub, or uh, is it gonna be a completely different stuff?
Sorry?
Now you are going for a lab, right? From the EC2.
Yes, yes, yes.
So are we gonna do we gonna push the image to Docker Hub and pull it from the Docker Hub, but how does it gonna work in the lab?
This lab I'm not planning to push actually. This is from basics. Okay. The requirement is how to deploy a containerized application from scratch. Then we can also push the image to Docker Hub, or else we can create a separate our own registry within our EC2 mission, and we can push an image to that registry as well. That is not a big deal actually.
Okay, okay.
It's a simple process. Just we can run Docker login. Okay, Docker login. Then it will asking for the Docker Hub credentials. So we can type the credential. Then we need to tag the image. Then push the image. So I will take Amazon Linux. Okay, that's fine. T2 Micro also fine because we are running a small size application. Okay, I am selecting one of the existing key pair. Then coming to VPC, selecting an existing VPC that we created earlier. Auto assign public IP enable. That's fine. Okay, we successfully log information. The next step is we need to install Docker. Okay, so these two stages are done. Okay, we select the EC2 with the operating system. That's fine. Now we need to uh, run our, installing Docker. So installing Docker, we need to use, first time changing my user to root user. Okay, So this is the Amazon Linux. So we use yum package manager to install any service. Okay. So yum install Docker. So we successfully installed Docker. Okay. So the next thing is we need to write up the Docker file. Okay. So we can after installing Docker, we need to use Docker commands to managing Docker. Okay. So some Docker commands are there. Docker PS for listing the running containers. So we need to verify okay the service is running or not using systemctl command. Status Docker. See it's inactive. So I'm going to start the service using the systemctl command. So systemctl start service names Docker. Now you can see it's active. So the first command is Docker PS, okay, to listing the running containers. In this case, there is no running container. That's why it's not list anything under the name tag. The next thing is we can run Docker images, okay. So it will listing the images that we build. So in this case, we did not build anything. So it's not showing anything here. So similar way, there is a lot of Docker commands are there. For example, we need to check some running containers logs, so Docker logs. Then the Docker container ID or name we need to define. So it will shows the logs, okay, the live logs. Then similar way, there is a lot of Docker commands there. For example, to build a Docker image, so we need to type Docker build, or to run a Docker build image to create a container, then we need to use Docker run command. So now we are good to create a Docker file. Okay, so I'm using a nano editor to create a Docker file D capital. So it's opened a Docker file. Okay, so here actually we need to define what are the things for the application. Okay, I mean the application code we need to define, application dependency we need to define, and a lot of things are there. Okay, for example, there's a lab actually there, right? You remember for deploying an application, deploy application, a web application using a EC2 mission, VM. You remember what are things that we did? First, we set up the EC2 mission, right? Then the second thing is we install the dependency for that application, that is the web server, right? We install HTTPD service. Okay, it's Apache actually. So next thing is uh, this is the process actually. This is the manual way we install. Okay, some effort there. Then the third thing is we copy or we keep the file actually, the application code file to the directory var www html. These are the two directory formed when we installing the HTTP actually. Then, yeah, then the last stage is I think we open the port number, right? For the security group, for the easy to mission, we open the port number 80. Okay, that these are the things actually we did last time, right? All of you,
Yes.
right?
So when we are installing the HTTP or something like that, you are saying that this where www HTML will get created. How we know,
Not
like
var actually. Var is there actually. This is
it's
actually there under
yeah, yeah,
the
okay.
only www2 directory.
So how will you know like where we need to go and check those ones? Like where is it comes from the experience or how does it gonna work?
Which one the directory, right?
Directories.
These are the default directories actually, where we are keeping corresponding service. Okay, for example, if we install Apache, the requirement is we need to expose or we need to expose some application, right?
Mm-hmm.
So that's a process. The Apache will serving our application contents. For example, this is a machine. Inside the machine, we install Apache web server. Okay, so some users are accessing our application. So the Apache will take care of that process. So Apache will taking the web content and send to the user. Got it. So
Mm-hmm.
Apache's whenever we install Apache, it will create a directory for keeping the web applications. I mean application code. So that's a directory www.html. So we need to copy or we need to keep our application contents, okay, the file and everything under the same directory. I mean HTML folder, we need to keep everything. The codes or the code related files, images or whatever we have. So actually Apache will looking for the directory HTML to take the application code and send it to the user or user can access the application actually.
Okay.
Got it. Okay. Then coming to the Docker file. I told you Docker files contain Docker instructions. Okay, instructions we define as uppercase. So we can start with the from instruction. So it's coming to the from instruction, we need to define the base image for the Docker container. So the base image is actually a minimal operating system. Okay, a small operating system with the minimal features. Okay, for example, it contains Linux workspace, small size. I mean, Linux binaries there. Like we can run apt or we can run like install apt install something, or we can see the similar like directories there, like var or uh, etc. Similar like directory we got. Okay, so that's actually a minimal version of operating system. That operating system contains a very small size actually when comparing to a full operating system. Coming to full operating system, 2 to 4 GB size we need to keep for the if whenever we installing. Okay, so the minimal operating system when coming to container part, it's around 100 MB or 200 MB like that. Also, we can define corresponding operating system with the low storage. Okay, so here we need to define any of the operating system. So I will go with some operating system that with the Rocky Linux. Okay. Only the instruction we need to keep as uppercase. Others we can keep it as a normal or lowercase. Rocky Linux. This is a Rock Linux operating system. Okay, we got a minimal Linux operating system that is called a Rocky Linux. So we need to define the username. This is actually, it will pull the image from Docker Hub. Okay, so I here define as a Docker Hub format, that is the Docker Hub repository name and the image name. So for example, if you have any repository there, then your name forward slash, then the image name. Okay, Linux. Okay, then the tag as well, we need to mention. Okay, I will choose the latest tag. This is the repository name, and this is the image name with the tag. We can see the same image. Okay, whenever we go into the Docker Hub, we can see this is actually an official image available in Docker Hub. That's fine. So the from part is done. Then next thing is coming to here. Okay, see, we install Apache, right? So same way we need to install Apache. So how we will installing Apache using container, then we need to use one of the instruction called run. So we need to type whatever we need under that run instruction. Okay, so the run instruction will execute or running the command that we are going to define here. So yum, the same commands that we did in local machine. Okay, yum dash y, then install. Um, Install HTTP. This is fine. So we installed Apache web server inside container actually. Okay, whenever it's built, it's installing the Apache web server inside container. Got it. Then the next part is see application code we need to keep under the directory www.html. So for that, here actually we need to keep the application code within the local machine directory. Okay, where we are going to run the Docker build. Got it. So for example, this is my local machine. Okay, the EC2 is our local machine. So we need to keep the application content within the local machine. Okay, so after that we using one instruction called copy. Copy, then we need to define the file name. Okay, here I am including only one file. Okay, index.html file. Then the path where we are going to send the file to the container. Okay, so the same path var www html index.html. That's fine. So what happened here? When coming to the copy instruction, the Docker looking for a index.html file and the same directory in the local machine. If we did not keep the index.html file there, we facing some issues. Okay, that copy is not completed that stage. If the file is there, it will take the file from the local machine and keep the file under the directory var www in the container part. This is a format actually. This is a host and this is a container. If the index.html file, HTML file in some other directory in our local machine, then we need to define the path as well here. Okay, similar like this. The next stage you can see here, open port. See, so coming to container, we need to open the port because container is a it's a virtual environment where we are going to deploy our application with the process and process networking everything. Okay, so we need to open the port number also coming to the container part. So we can use for opening port, we can use the instruction expose. Then type the port number. 8 is fine for my web application. Okay. Then one more thing we are going to do, whenever the container, the requirement is like this. Okay. Whenever the container is start, we need to ensure that our application or the web server is running fine. So for that, we can use one instruction like entry point. Then we need to define the binaries. Okay. For example, this HTTPD there is a service called a binary service there. Okay, so that service actually we need to start whenever the container start. So we can define that Apache binary file. So the binary file belongs to the directory user sbin HTTPD. Okay. Similar way, if you install any service, okay, all the service belongs to the same directory. Then we need to define the service running in background. Okay, so we need to define D foreground. There is a format there. Okay, coming to entry point. The first part is this is the first part. This is a executable path. Okay, not path actually. This is an executable file we need to define here. So executable, first executable. Then second thing is the argument. You can add more argument here. Okay. So here I only want include one argument. So that's format coming to entry point, executable and argument. So this is fine for running a application, a web application that we did in the same easy to vision. Okay, before. So I'm going to save and exit. So here you can see the Docker file is here, but we did not create a index.html file here. So I'm going to create index.html file. If we have any application code like HTML file, then we can keep the file inside the HTML. So in this case, I just write some word only. Okay. Now fine, we can build our application. I mean Docker file. Okay. So to build Docker file, we need to use Docker commands. Okay. So the commands I told you, Docker build, Docker run. There is a lot of commands are there. Docker commands. Okay. I will share the Docker commands list later. So in this case, we have a Docker, we created a Docker file and we have an application code. Okay, as of now, we don't have any container. Okay, see Docker PS, nothing. Docker images, nothing there. So first thing is we need to build the Docker file. Okay, so we can use Docker build command. Build dash T for the name tag. Then we need to define a name for the build image. Okay, any name we can define. Okay, for example, new app. Okay, or GS. Then space dot. Okay, so it will taking all the files from the same directory. So hit enter. So it will starting building actually. See. So coming to building, okay, there are different layers are there. Okay. Run em. Okay, I put a space between. See, will open the Docker file. Can see the error here. Okay. So here I use a space between the dash and y. There is no space actually. This is a flag actually. Dash by flag means it will, whenever it's asking for yes or y. Okay, so we need to manually type yes or to install, we need to type yes or to, I mean, abort, we need to type no. So coming to this process, we can't do that. Okay, so we can include the flag inside the Docker commands. This is not Docker commands actually, this is a normal command. Okay, then I am going to save and exit again. Then I am going to build. So what are the things that we define in the Docker file will start here? Okay, first is it will downloading the HTTPD. So here all the instruction we can see in different layers actually. Okay. So see, three layers are there. So that way is 3 by 3 here. And we can see the logs as well. Copy index or file to directory, everything seems fine. Now it successfully created an image. Okay. So I will try to see the image, Docker images. See, this is our image. And you can see the size of the image, including the base image, everything. It's only 278 MB. So the next thing is we need to run this image, okay, to create a container. As of now, we did not create container actually. So for that, we need to use docker run command, docker run dash D. This is for detachable mode. Okay, whenever we hit enter, the process will go on and we can the terminal will free. Okay, we can use the terminal. So dash D. Then we need to define the port number. Okay, for accessing our application. So here actually, this is the machine. Okay, this is the EC2 machine. So inside the machine, we install Docker and everything. Okay, Docker there, Docker. So on top of Docker, we are going to create a container actually. Okay, this is our container. Okay, container. So we already opened the port number 80 for the container, right? Using the Docker file. But how we will accessing the application, the container application outside? I mean, a user, a remote user. Okay, first we need to because this is the EC2 mission. This is the EC2 VM. And inside the VM, we install Docker. Then we creating a container. Okay, now we are going to create a container. So the requirement is this is the application. So how the users accessing the application, the remote user. For the previous case, we deploy a VM, a EC2 machine, and we install the Apache inside the machine. And how we will access the application using the machine public IP plus the port number, right? 80. For 80, we did not define because it's HTTP default HTTP port number. So using the public IP, we can access the application. So in this case, how we will access the application? We need to do one more thing that is called port binding. So coming to port binding, the way we accessing the application using the public IP, okay, there is no difference. Using the public IP of this EC2 machine where we install the Docker, then we need to define the port number as well. A port number like any port number we can use like 80, 81, 82 like that. Okay. Then we need to, before accessing, we need to done this part, okay, the port binding. So here, for example, the container port is 80, right? And we need to send the traffic to the container port 80. I mean, that job done by the port binding. So the port binding look like this. Port number 8. If we're using 80, then we need to port bind like this. Okay. 80, then 80. The first 80 is the host port number. The second port is container port number. So this is a format. So here actually, if we open the EC2 machine port number 80, okay, then we will use, when we define the port binding like this, that means the EC2 machine's port number 80 is binded with the container port 80. So any request, then how we will access it? The same way, like public IP of the EC2 machine, then use the port number 80 for the EC2 machine, okay? So any request hitting to the public, I mean, the EC2 machine port number 80, that is routed to container port 80 using the port binding. Got it. For example, we deploy one more application, okay? One more application. We can open port number 80. There is no conflict because I told you containers are running isolated way, okay? So there is no conflict if you open port number 80 to any other container. Then coming to the machine, okay, EC2 machine, we already allocated port number 80 for the first container, okay? This is our second container. Then here we need to change next port for the EC2 machine. We can use 81. And here changing like 81 to 80. That's all. So the 81 is, then now we will access an application, public IP with 81. Public IP, then the 81. So that is routing to second container. So this way we using port binding, okay? So the port binding we can include whenever we is running the container, okay? So for that we need to use the tag like -p. Then we need to define the port number we are going to binding. So the container port 80 binding with the, sorry, OS estimation port number 80 binding with the container port 80. Got it. Then we need to define the name for the container actually. We are going to create a container, right? So we need to define a name for our container as well. Like my first app, my first container. Okay, this is fine. Then we need to define the image for the application. So the image is, we can use this image, right? So GS new. That's fine. Okay, see it's created. And we can check the container status. See, container is started. So when typing Docker PS, we can see the running container. So the container ID, the image that we are using for the run container. Then the command, it started 6 seconds ago. And the status, that is up. Port number, everyone can access through the port number 80 to this container, okay? And the container name. So now we need to access the application. For that, just to go back and open the port number. Okay, as of now, we do not open the port. So go to the EC2 mission and go to the security group. Open the port number 80. We open the container port 80, but we are not open for the EC2 mission. So here we can use HTTP. HTTP, okay. Save row. Now we need to take the mission public IP. This is the public IP and we did not mention the port number 80, okay? It will take actually. My application is not taking, okay? I will check.
You have given the, like, in the Docker file, you have given HTML, index.html has given wrong actually. You have spelled wrong in Docker
No, this
file.
is right, right?
That one is right, but when you're going into Docker file, you have spelled it wrong.
Okay. Oh, sorry, sorry.
Copy. Yes.
So this is running container, okay? So how we will stop the container? Docker stop. Then the container name or container ID. My first. So now you can see it's stopped. So we need to remove. If we need to remove, then we can use Docker remove. rm my first. So it's completely removed. Okay. So the port number also we can use the 80 for the EC2 machine. So it's free. So now we need to do the same process, Docker build it again because we changed some file, right? So I'm not I will use one new image, okay, GSN. That's fine. Then running the container. Only define the GSN, okay, that's fine. Docker PS. We'll run it again, okay, it will take. Yeah. See.
Is there a way that we can modify the running container instead of deleting it and creating it again?
Yeah, we can modify as well. For that, first we need to remove the container, okay, because that container using the port number. Now the port number EC2 machine 80 port number is reserved for this container. Now we successfully deployed one container, okay, one application then see Docker BS. So quickly we can deploy one more container, okay. So simple way we need to change application. Just open the index.html file. I'm changing some text okay here and save. Now we need to run it again. It's the same commands. So when running the second container, okay, we need to change the port number. Otherwise, we will face conflict because the 80 is reserved for that. Also the name for the container. So I'm changing to, I mean, adding some one or two like that. Docker yes. So here we can see two containers are up and running. So accessing the second container, we need to open the port 81 in EC2 instance. The similar way we can deploy containers within application container. Okay. So I'm opening 81. Then copy the IP. Then paste it here. Okay. 81. See. So this is the second container. And this is a first container. So this is the way we deploying different application using Docker. So if we have the Docker file, okay, a similar type Docker file, then we can use the Docker file. So how easy we can run application. It's simple, right? So anyone have a doubt?
So can you show us like how to access not from the Amazon console, rather from Putty or Mobile Extra?
I mean, accessing machine, right?
Yes, EC2.
Yeah, sure. Okay, to accessing a machine using Putty or Mumbex team, we need to first we need to identify the machine uh, key. Okay, so and second thing is we need to ensure that the keys belongs to the same machine that we are working. So in this case, I am using these machines, and the machine key is
DB,
yeah,
DB
DB.
firm. Mm.
Yeah, this is a key. Okay, so I am checking the DBs belongs to I mean existing in my local machine. Okay,
Okay.
because I'm using different PCs. So the DB is not in here. Okay, so I will quickly launch one machine and show you how to remotely access.
You can download it. Oh, once you can't download. Yeah.
No, no, no. We
You
can't
can't.
download.
Yeah, I agree.
Otherwise, we need to take the public key from the machine and we need to use some application to convert it to private key. That is complex. Better we need to keep see here the coming to the keeper, create a new keeper. Okay, this only is fine. Create new keeper and type. And here we can see that encryption type, okay, RSA and ED25515. So we can go with the RSA and the private key file format. Two file format are there. One is .pem and .ppk. So we can go with the PEM key, okay. Or else if we use to, using from putty, then we can take PPK file. Or otherwise, we can use puttigen. Okay, there is a puttigen there. Then using the puttigen, we can convert the PEM to PPK as well. In this way, we can directly download the PPK. So I'm going with the PEM. That's fine. So it's the file is downloaded in my local machine. Then we need to define test public devops slash file. Enable public AP. Otherwise, we can't log in the machine. Okay. So that's fine. Launch. I opened the port number 822. Okay. I'm not actually, that is default opening the port number 22 whenever we select the Linux machine. If you select any Windows machine, then it will automatically open the port and RDP port. Okay. Now the next thing is we need to share. I will use Mobix team. Okay. Mobix team. This is the application. Or else we can use Putty as well. Okay. So selecting the Mobix. This is a client application to we can take remote connection from a lot of services. Okay, go to the sections. See here we can see that protocols like if we use SSH or Telnet, RDP, a lot of protocols are there. So in this case, the machine is a Linux machine. So we need to use SSH connection, SSH protocol to remote access. So here we need to define selecting the SSH, then we need to define the remote host. That means that machine public IP. So copy the public IP and put it here. Then specify username. Default username is EC2 user because that is a Linux machine, Amazon Linux. EC2 user. If it is Ubuntu, then we need to define Ubuntu. Okay.
Oh,
Then
it
see
depends upon
advanced.
the image.
Right. If we have any specific user, then we can define that. But as
Okay.
of now, we didn't create any user there. So next thing is we can log in as root as well, okay, instead of EC2 user. Then coming to advanced SSL settings, we need to define the private key. Okay, the key that we download. So two keys are there. One is private key and public key. Public key belongs to the machine. I
Machine.
mean the remote machine. And the private key we need to keep. Okay. Coming to the authentication, this private key and that public key should match. Otherwise, it will throw error. I mean, deny the access from the server. So select use private key and open the key that we download. Okay. So GS. That's fine. Click OK. It will start to authenticate the remote access. Got it. Now we successfully log into the mission. So this is a way we remotely taking via MobX team. Now coming to the PuTTY, see here we need to define the public IP. Then the phone number is that's fine. Now coming to the SSH authentication credential private key. See define the private key here. Downloads. Coming to here all files. Okay. Yes. Open. Accept. Here we need to use PPK, okay, instead of
PPK.
PEM.
Yeah, yeah. We have downloaded PEM. Okay.
Otherwise, we can use the puttigen. See, here there is a puttigen here. Open the puttigen. And here we need to load the key first. Download. No need to generate actually. Puttigen. No, it's saved actually. We can try with that. Yes. Okay. This is a key we converted.
Okay.
Yeah, fine. This will ask you for the username actually. EC2 user. Yeah. So just typing the username. Okay, we did not define the username in the putty main putty application. That's why it's asking for the username.
Okay.
This is a way we taking access from putty and Mobexty. Got it.
It's the same. It's the same process, right? Whatever we have done on the EC2 like instance, it will. I think that will have that
Yeah.
Docker install. Everything is installed in this one.
Right, right. No, no, no.
Okay.
I didn't hear. Come again. Coming to the Docker part.
So, yeah, we have already installed the Docker on that instance, right?
Hmm. Yep.
It means it is already installed in this. We can make use of like we can see Docker PS and something. We can give it, and it it should give us the list of the containers.
From this machine, right?
Uh-huh.
We did not install Docker in this machine actually.
Oh,
This is a new machine. We can install Docker using sudo yum install Docker.
okay. Okay.
because this is a second mission actually. We here you see for the Docker mission we don't have the key actually, so I created another
Oh, yeah,
mission.
yeah. No, oh, got it. I thought it was we are making use of the Docker. Okay, got it.
Oh. Now I am installing the Docker for the second mission from Putty. Okay, see
Okay.
now we can run Docker PS. You need to start using systemctl. Use sudo as user.
And Taufik, is there a way that like do we need to use this particular image like whatever you have said like some image right you have from what is it? It's the first time I'm hearing that image actually. Is there something like we can make use of? How do we know which image to pull, like get from the Docker Hub?
Yes, that's as per the requirement. We need to define corresponding images. Okay, going forward, I will show you for different applications. So as
Okay.
per the application requirement, we can define the image size, image as well. For example, we need to. This is for Apache. Okay, so we use a base image, but some other web server, for example, Nginx. Nginx have their own web server. Okay, for coming to the Docker part, Nginx have in there is a official image. That image contain the base uh, operating system as well. So we can
Okay.
directly pull the image from the registry. I mean Docker Hub, and we can run the rest of the. I mean the copying symbol like that we need to. So for example, coming to the Docker file, we need to define the from instruction. Then we can define Nginx. Got it. So it
Okay.
will take the Nginx web server with the minimal operating system as well. So we got the some minimal features for the Linux,
Mhm.
including that image actually.
And one more question. I don't think like we'll be using in the real time. Are we using to like we are creating our own image, right? Instead of pulling it from because um, requirements will be different. So we might be creating our own image and we'll be pushing that rather than.
Right. We need to create Docker file actually whenever we are going to deploy any application.
So are you going to show us like how to like getting the source code file from GitHub to copying
This is
it
a
in the
minimal
content?
example. Today is the one of the example. You know,
Mm-hmm.
before Docker, how we will deploy the HTTP application, and coming to Docker, the same process, right? We need to create a Docker file and define everything. The manual process that we done in the previous EC2 case. So all the steps that we include in the Docker file, like the installation of Apache, then copying file using copy instruction, then open the pod using expose instruction like that. So
Okay.
this is for a web application. Like for example, it's a Java application. Then first we need to know how the Java application we run in a local machine, like or a virtual machine. The same steps we need to include in the Docker file. That's all.
Got
For
it.
Node.js application or Python application, everything seems same.
Mm-hmm.
So I will show you a Node.js application, or yeah, we can do some different types of language application tomorrow. Okay, like
Okay.
Node.js, Java, like that.
Okay.
So the Docker file looks different. Okay, coming to different application.
So we are trying only on web application right now, and moving forward, we might be using instead of web application, we might be using something else. So that, um, but I don't know how it works with the uh, getting the code from the source and copying it into the container so that we can make use
Right.
of yeah application which is in the source code from the GitHub.
Yeah, I'll show you. Okay. For example, we have some applications in GitHub, right? So GitHub. So GitHub contains our application code. Then a lot of files are there, like application source file, the code, index.html file, or some other files like images. So all these files under a GitHub repository, right?
Hmm?
So using this, you need to create a container, right? That's a requirement, right?
Yes.
So first we need to clone using git clone.
No, I have the idea. Like, are you going to show that in the lab
Yeah,
too?
yeah, I will show you. I will show you.
Okay.
Tomorrow we can use some Java application, okay?
Okay.
Along with the Node.js also.
Okay. Sound good. Thank you.
Is anyone having it out? Otherwise, we can wind up today's section, right? All of you.
Sure, no
All
problem.
good, right?
Thank you. Have a good
Okay.
morning, good night to everybody else
Bye-bye.
for the class.
Yeah.
Bye.
We'll
Bye.
we'll connect
Take care.
tomorrow, okay?